Welcome. This is a little start to the ideal gas B worksheet. The difference between the ideal gas previous that we have is we had a worksheet on the ideal gas law PIV-NERT, and we also had one for the combined gas law. At this point, this worksheet, you're going to have to be able to read through the problem, identify which of these two you are going to be running. They do work slightly differently. This guy contains moles, which can therefore also be kicked back and forth to a mass. So when you read through a problem, ask yourself, which of, is it contain either of these two? This is a really unique because it has sort of a before and after scenario. So as you read through your problem, ask yourself, is that something that that would pertain to that problem? All right, number one, units on R. Well, this is an algebraic problem. PV equals nRT. If you solve for R, PV over NT equals R, then these are my units. It's going to be atmospheres, liters, moles, Kelvin. That is my units on R. A sample of helium gas, STP, has a volume of 5 liters. How many moles? So at this point, I'm not going to go through the answer because you guys can do that. But because it asks for moles, this is a PV equals nRT problem. I lost my N there. nRT. And I'm solving for N. PV over RT equals N. You guys can take that one from there. A balloon of hydrogen gas at STP, 5 liters. How many moles are present? That looks like doesn't look any different than the previous problem. I see. This one is helium, and this one is nitrogen. So, in reality, it's another PIV-NERT problem. PV equals nRT. I will note that because we have the same conditions, same exact problem here, RT equals N, there's going to be no difference in the mathematics. So these two are going to equal each other. Equal moles, but not equal mass. It's not asking for mass, but, all right, in that case, we'll have the same number of moles. Just happens that the nitrogen is much heavier. Hence, the nitrogen will sink and the helium will float. All right, if a balloon if a balloon at STP contains 10 moles. All right, right away, moles. PIV-NERT. PV equals nRT. Mass. Okay, didn't convert the moles to mass. Next, a balloon contains 1 gram of nitrogen STP. What's the volume? Okay, so grams will go to moles, and then we'll be using PV equals nRT. So take a moment and just jot down on the side which equation we're going to use, and then you can get started on your own. I would say pretty much all of these so far. Remember, 212 is 0 degrees Celsius. I shouldn't say that. It's 100 degrees Celsius. So 100 degrees Celsius, and then 200 and 373 Kelvin. All right, moles. All right, moles. All of these are going to be PIV-NERT. And the balloons, previous problem, okay. All right, so this one here, so up to this point, the balloons from the previous problem are released into a rigid container of 1 liter in size. So this is our first combined gas law, P1V1 over T1 equals P2V2 over T2. Now it says the balloon, the previous problem, so the previous problem is going to have a some volumes, and I will let you take a look at that one. And then of course the spark ignites the creating water. What mass of water is produced? All right, this is a little harder. Okay, so we're going to take, in this case, the hydrogen. Hydrogen plus oxygen yields water, and we'll need to create an ice table. And this is relying on the previous stuff from our previous chapter, and I will give you a chance to essentially work this thing through. A couple things you want to know. These guys have to be in moles. Once you're in moles, essentially they want you to find your ending moles of water and convert that back to mass. Right? How do you get the moles? We'll use PIVNRT. PV equals nRT. The moles will allow us to get in there. All right, so that's a preview of that. Mostly this is going to be the PIVNRT, all right, and one combined gas law, one little stoichiometry problem. This is our chance to work on some of these problems. More answers will be coming later. Thank you.